for lesson 35, we're going to take what we did last lesson and actually do something with that greatest common factor. And it's called factoring it out. Basically, if we've done the distributive property, right? What this would mean would be multiplying this times everyone inside, so 2ax plus 2ac. What we're doing in this lesson is instead starting with this and ending up. So we're undoing that. We're reversing the process and ending up like this. So there's a trick from getting from here to here. In fact, what they did was they said, okay, what's the greatest common factor of both of these? Well, they each have a 2 and at least one a. So there it is. That was the greatest common factor. And what they did was divided each of these by that term. Or we took out what we divided, or took out what we took this out and what we're left with. So if we take out a 2a from this term, we're left with an x. We take a 2a out of this term, we're left with a c. So that's how we undo it. Let's go ahead and try it. Oh, I just showed you. Factor the greatest common factor of 2ax. So you do need to write it out first. And then factor out the greatest common factor was 2a, and what's left is x plus c. Okay, we're going to get more complicated, of course, because that's what we do. Factor the greatest common factor of ax cubed, all this. Okay, I'm not going to say it all out, it'll take too long. So what we do is find the GCF, the greatest common factor of each of these. Well, it looks like they all have at least an a squared. They all have at least 1x, and they have at least an m squared. Okay, so if we take out of this first term, if we take out a squared, what are we left with? We take 2 of them, we're left with 1. If we take one of the x's away, we're left with 1x. If we take m squared away, no one is left, so we leave it like that. Next one, if we take a squared away, nothing is left of the a's. Nothing is left of the x's. And if we take m squared away, we have 1m left. And then go ahead and make sure we follow the pattern of the signs. So if we take a squared away from a fourth, we subtract, we get a squared. If we take 1x away from x cubed, we subtract, so we've got x squared. And we take all this m's away, it takes m squared out of m squared, and that's what we're left with. And a good way to check to make sure you did it right is to distribute. Multiply this times this, multiply this times this, and multiply this times this to see. So you can check. You can always check these, and here's how. Multiply this term times this term. So we get a cubed x squared m squared. Then we would multiply this term times an m, so that will just increase the number of m's here. So we get a squared x m cubed. Then this times this, so we would now have, minus a to the fourth x cubed m squared. Now we know we did it right is after we distribute it back through. Does this match our problem? Let's check. Yes, yes. So that's how you can check, is if you distribute it, you get what you started with. Kind of reverse, then come back. And then you know that you have the right answer. So if this were on an assignment, I definitely would know that this would be too much for the grader to look at, so I would definitely box that as the answer. Example 3, now we've got a coefficient in here, so we're also going to look at the numbers. 2 is the biggest thing that goes into both of those. And then we look again at the smallest number of a's. They all have an a squared. They all have a b. And they all have a z cubed as the highest. And now we're going to pull that out. So if we pull out a 2, we do 4 divided by 2. a cubed divided by a squared, which is, we subtract the exponents. 3 minus 2 is 1. b to the fourth divided by b would be 4 minus 1. Z cubed divided by z cubed is just 1. We get nothing. Those get to just cancel out and turn into a 1. Plus, now 2 divided by 2 is 1, so the coefficient is gone. A squared is gone. B is gone. Now all we have is z to the fourth divided by z cubed, which is z. And so that is our final answer there. Alright, I really recommend you try these on your own before you watch me do them. So like example 4, go ahead and give it your best shot. Pause this and then see how you do. So I see they each have a 2. They all have an a squared. And they all have an x squared. Now when I pull that out, I have a 3. And my a squares, x squares are taken out, so that's gone. Plus 2 divided by 2 is 1. And so it looks like I have an a x left, because those are cubed and these were squared. Minus, and then 2 goes into 4 2 times. And we have a squared left and x to the 1 left. And there we go. Factor the greatest common factor of this. So they don't have a coefficient that is common. So we don't get to pull anything out between 3 and 1. But they each have at least an m squared. They have at least they don't have an x each, so we just skip the x, and they do have a y. So that is the greatest common factor. And what's left then is a 3mxy. And double check. If we multiply those, we get m cubed. Multiply this times, that would be an x, and these two, we get a y squared. Plus, now we already took out all the m's, and we took out, what happens when these are the exact same? We took everybody out. So this divided by this is what? This divided by this is 1. And so there is our answer. People forget this a lot and leave that out. It's plus 1 if these are the same. Now we're going to switch gears and talk about canceling. Another common mistake I see, or teachers see in algebra, not just me. So let's look at this. If we had 4x over 4, we could cancel out the 4's. So yes, that's allowed. Here is something different, but we make this mistake a lot. If we have this, can we just cancel out the 4's here? No, it's not correct. So I really want you to see when it works and when it's wrong, right? Illegal. We can't just cross these out because these are separated by addition. These are separated, this is multiplication. So when you're joined by multiplication, you can divide. When you are joined by addition up here, we can't just divide. So here's another one where we could. If we had this, because 4, this means 4 times x plus 1. So that means we can cross these out. So let's look at this down here. Can we cross these out? Yes, this is like this pattern up here. Those 4's can cancel out, and so we get a minus 3. All right, now let's look at this. Can we cross anything out? We can, because we're crossing this whole thing out. And it was joint to the 3 by multiplication, so that is allowed. This one, we cannot just go and cross out those 3's. What we can do is first factor. We always factor the top and the bottom if we can. So we go, what's the biggest thing that goes into both of those? A 3. So we're factoring this, is which we did on the first page. We take 3 out, we're left with p plus 1. And you can check. What is 3 times everything in here? 3p plus 3. So that works. All over 3. Now this is a pattern like this one that we can actually cancel out those 3's, so the answer is b plus 1. Again, factor first if you can. Is there something that goes into the top here they both have in common? Well, 3 goes into both of those, and x goes into both of those. So if we factor out a 3x, we're left with a 1, minus, if we take 3x out of this, we get 9 divided by 3, and x minus 1. So now we have this, don't we? Now these two quantities are attached by multiplication, which means that these two can cancel out. And so the answer is 1 minus 3x. Let's do another one. Factor or simplify this. Again, factor the top. 5x goes into both of those. And when we divide that out, we get 1 minus 5x. Does 5x times 5x equal 25x squared? Yes, it does. And are these joint by multiplication? Yes. And in fact, all of these guys are joint by multiplication. So that means we can cancel out stuff from these two terms. We can cancel out the 5 and the x. Now let's see, we have 1 minus 5x left over y. Okay, you have 4 practice problems. Really try these and then come back. Don't watch me do them, try them, and then come back if you get stuck. All right, so it looks to me that 5 goes into both of those, and they each have an a, then they each have a z to the 5th. And so 15 divided by 5 is 3, a squared divided by a is a, z to the 8th divided by z to the 5th is z cubed, minus 7, z to the 5th, and a. Oh, so it looks like it's just 7. There we go. Next one. Okay, it looks like 2 goes into everything. And they all have an a and they all have a b. Just how many a's do they all have? All right, a squared is the greatest one that goes into all of them. And they all have at least a b squared. So notice that this is the same as that. So this times 1 equals 2a squared b squared. Plus, now it looks like a cubed divided by a squared would be just an a, and then those turn into a 1. A cubed, a squared gives us an a. B to the 6th divided by b squared is b to the 4th, not b cubed. Remember, we add and subtract exponents when we multiply and divide. That's kind of a tricky one. It might be a hang-up for you for a while. All right, simplify if necessary. Some of these might not be simplifiable, but let's look. Can we factor? Yes, 4 goes into the top. And it looks like that if we factor it out. 4, because if we multiply this through, we get 4 times 1 is 4. 4 times negative x is negative 4x, all over 4. Now these two are attached by multiplication, so that means this is legal. 1 minus x is, so we take something like this and now we've simplified it into something more simple, which is why we call it simplified. All right, so again, I see that we can factor 7x out and we end up with this. And because those are together with multiplication, then this is allowed. Oops. 1 minus 7x is the answer. And there we go.